Hello everyone, in this video I'm going to discuss the example for function and graph. The function f and g are defined as where we have the fx which is equals to ln bracket x minus 1. For the function g, we have gx is equals to modulus 1 minus x plus vector 2. Find the inverse of the function g if its domain is x greater than 1. Before we find the g inverse, let's define the situation modulus 1 minus x plus vector 2. So 1 minus x plus vector 2. 1 minus x greater equals to 0. Negative 1 minus x plus vector 2. 1 minus x less than 0. So kindly refers to the situation we have 1 minus x plus vector 2. So we will have 3 minus x, where we have the domain x less than equals to 1. Continue, we have negative 1 plus vector x. So we have the x, negative 1 plus vector 2. So we have plus 1. X greater than 1. So after we define the situation, so the function of gx, it should be, focus on this part, they said the domain x greater than 1. So we only pick the x plus 1. So that is the function for gx. So find its inverse. So let y is equals to gx. G inverse of the y which is equals to x. So let's begin. Y is equals to x plus 1. X is equals to y minus 1. So G inverse of the x, we have x minus 1. So that is the inverse function of the G. Next, kindly refers to B. Find the inverse and its domain and the range. So let's focus on the fx. We have the domain for the fx. So x minus 1 greater than 0. So x greater than 1. So that is the domain for the fx. 1 until infinity, where the 1 is not included. Next is to find the inverse. So let the y is equals to fx. So f inverse of the y is equals to x. So let's begin. Y is equals to ln bracket x minus 1. Kindly express the x as a subject. So we have the exponent y plus the 1 which is equals to x. So f inverse of the x which is equals to exponent x plus the 1. So refers to the situation, the domain for the f inverse which is equals to, because of the exponential function, so the domain will be definitely infinity, negative infinity until infinity. As for the range for the f inverse, as we all know, it is the same for the domain for the f. So the range for the f inverse would be 1 until infinity, where the 1 is not included. C. Hence, sketch the graph for the f and f inverse on the same axis. So let's focus on the function of fx. First what we have is the domain 1 until infinity, where the 1 is not included. Second, we have the asymptote, x is equals to 1. Third, the direction. What we have is, refers to the situation, we have ln. Then we have the coefficient of x, which is a positive. So it's a positive, so the graph will be moving towards the right. Next, find the x-intercept when y is equals to 0. So we have 0 equals to ln bracket x minus 1. So exponent 0 plus the 1 which is equals to x. So x is equals to 2. So we have the x-intercept coordinate 2, 0. Next, focus on the graph. So at first we have domain 1 until infinity. So let's say here we have the 1. So x is equals to 1. Next, the graph is something like this, where we have the coordinate 2, 0 in here. So where we have the function fx which is equals to ln bracket x minus 1. Next is to sketch the inverse. So in here I'm going to reflect the situation based on y is equals to x. So here we have the axis y equals to x. So now we are going to sketch the graph for the f inverse based on the y is equals to x. So we can say the function fx reflect based on the y is equals to x. Focus on the x is equals to 1. That is the vertical asymptote. So if we reflect, you will have the horizontal asymptote where we have y is equals to 1. Next, focus on the point. We have 2, 0. If we reflect, it becomes 0, 2. So the graph will be something like this. That is the F inverse, where we have F inverse is equal to exponent x plus theta 1.
If you are new here, kindly consider subscribing to this channel and share this video to your friend. Thank you so much for watching this video. Bye.